Welcome to Mind Map MCQ. In this video, we learn about layers of Earth through various multiple choice questions. So prepare, practice and prevail. 1. Which of the following layers is the outermost layer of the Earth? The options are A. Core, B. Mantle, C. Crust, D. Inner core. The correct option is C. Crust. The outermost layer of the Earth is the crust. It is a solid, thin layer that forms the Earth's surface consisting of continental and oceanic types. The continental crust is primarily composed of granite, while the oceanic crust is mainly basaltic. The crust varies in thickness, ranging from about 5 km beneath the oceans to up to 70 km beneath the continents. It forms the lithosphere along with the upper part of the mantle, which is divided into tectonic plates. 2. What is the thickest layer of the Earth? The options are A. Mantle, B. Crust, C. Outer core, D. Inner core. The correct option is A. Mantle. The thickest layer of the Earth is the mantle, which lies between the crust and the core. It extends from about 30 km to 2,900 km below the Earth's surface. The mantle is composed primarily of silicate minerals rich in iron and magnesium. It is divided into upper mantle, including the asthenosphere, and the lower mantle. The mantle is solid but behaves plastically over long periods, allowing for convection currents that drive plate tectonics. 3. Which layer of the Earth is liquid? The options are A. Crust, B. Inner core, C. Mantle, D. Outer core. The correct option is D. Outer core. The outer core is the only liquid layer of the Earth. It lies beneath the mantle and above the inner core, extending from about 2,900 km to 5,150 km below the Earth's surface. Composed primarily of iron and nickel, the outer core's liquid state is due to the high temperatures which exceeds the melting point of these metals. 4. The Earth's inner core is primarily composed of which elements? The options are A. Silicon and oxygen, B. Iron and nickel, C. Magnesium and aluminium, D. Sodium and potassium. The correct option is B. Iron and nickel. The Earth's core is primarily composed of iron and nickel. It is a solid sphere with a radius of about 1220 km located at the center of the Earth. Despite the extreme temperatures estimated to be as high as 5400 degrees Celsius, the immense pressure keeps the inner core in a solid state. The high density of iron and nickel contributes to the inner core's composition, making it crucial for Earth's magnetic field and geodynamo process. 5. What is the primary composition of Earth's mantle? The options are A. Iron and nickel, B. Granite, C. Basalt, D. Silicate minerals. The correct option is D. Silicate minerals. The Earth's mantle is primarily composed of silicate minerals rich in iron and magnesium. The main constituents include minerals like olivine, pyroxene, and peridotite. 6. The boundary between the Earth's crust and mantle is called what? The options are A. Lithosphere, B. Asthenosphere, C. Mohorovičić discontinuity, or D. Gutenberg discontinuity. The correct option is C. Mohorovičić discontinuity. The boundary between the Earth's crust and mantle is Mohorovičić discontinuity, commonly known as the Moho. This boundary was discovered by seismologist Andrija Mohorovičić in 1909. It marks a distinct change in seismic wave velocities, indicating a transition from the less dense crust to the denser mantle. The Moho lies at varying depths, approximately 5 to 10 km beneath the oceanic crust and 30 to 50 km beneath the continental crust. This discontinuity plays a crucial role in understanding Earth's internal structure. 7. The lithosphere is composed of which layers? The options are A. Crust and core, B. Crust and upper mantle, C. Mantle and outer core, D. Inner and outer core. The correct option is B. Crust and upper mantle. The lithosphere is composed of the crust and the uppermost part of the mantle. It is a rigid outer layer of the earth averaging about 100 kilometers in thickness but varying depending on whether it is oceanic or continental lithosphere. The lithosphere is broken into tectonic plates that float on the semi-fluid asthenosphere beneath them. This structure allows for the movement of plates, which is responsible for geological phenomena such as earthquakes, volcanic activity, and the creation of mountain ranges. 8. Which layer of the earth is responsible for generating the planet's magnetic field? The options are A. Outer core, B. Crust, C. Mantle, D. Inner core. The correct option is A. Outer core. The outer core is responsible for generating the Earth's magnetic field. Composed primarily of liquid iron and nickel, the outer core's convective movements create electric currents. These currents produce a magnetic field through the geodynamo process. The motion of the liquid metal generates and sustains the magnetic field, which extends outward into space and surrounds the Earth. This magnetic field is crucial for protecting the planet from solar wind and cosmic radiation, making life possible on Earth. 10. The Earth's crust is divided into large slabs called what? The options are A. Plates, B. Layers, C. Sheets, D. Bands. The correct option is A. Plates. The Earth's crust is divided into large slabs called tectonic plates. These plates are part of the lithosphere, which includes the crust and the uppermost mantle. There are 15 major tectonic plates, including the Pacific plate, North American plate, Eurasian plate, and African plate. Tectonic plates float on the semi-fluid asthenosphere below them, allowing them to move. This movement is responsible for many geological phenomena such as earthquakes, volcanic activity, and the creation of mountain ranges through processes like plate collision and subduction. 11. Which of the following is not a type of tectonic plate boundary? The options are A. Convergent, B. Divergent, C. Transform, D. Slip. The correct option is D. Slip. Tectonic plate boundaries are regions where two plates meet, and they are classified into three main types. Divergent, where the plates move apart, creating new crust, example mid-ocean ridges. Convergent, where the plates collide, leading to mountain formation, subduction zones, and volcanic activity, example Himalayas, Andes. And transform, where the plates slide past each other, causing earthquakes, example San Andreas Fault. These boundaries are dynamic and are key to the Earth's geological activity, shaping the planet's surface over millions of years. 12. What is the main source of heat within the Earth's interior? The options are A. Solar radiation, B. Chemical reactions, C. Radioactive decay, D. Ocean currents. The correct option is C. Radioactive decay. The main source of heat within the Earth's interior is radioactive decay. The decay of radioactive isotopes such as uranium-238, thorium-232, and potassium-40 generates significant heat. The heat is produced as these isotopes break down into more stable forms, releasing energy in the process. Additionally, residual heat from the planet's formation and the heat from gravitational compression also contribute. This internal heat drives mantle convection, plate tectonics, and volcanic activity, playing a crucial role in the Earth's geothermal processes. 13. The plastic-like behavior of the asthenosphere is due to what? The options are A. High pressure and low temperature, B. Low pressure and low temperature, C. Low pressure and high temperature, D. High pressure and high temperature. The correct option is D. High pressure and high temperature. The plastic-like behavior of the asthenosphere is due to its partially molten composition and the high temperatures and pressures within this layer. The asthenosphere located beneath the lithosphere in the upper mantle contains a small percentage of molten rock which allows it to flow slowly over geological time. This ductile nature enables the rigid tectonic plates of the lithosphere to move on top of it, facilitating plate tectonics. The asthenosphere's ability to deform and flow is essential for the movements of arch plates. 14. How thick is the arch inner core? The options are A 1200 kilometers, B 500 kilometers, C 2400 kilometer, D 3500 kilometer. The correct option is A 1200 kilometer. The arch's inner core is approximately 1220 kilometers thick. It is a solid sphere composed mainly of iron and nickel located at the center of the earth. Despite extremely high temperatures estimated to be around 5400 degrees Celsius, the immense pressure at this depth keeps the inner core in a solid state. The inner core is surrounded by the liquid outer core which extends to about 2200 kilometers thick, generating Earth's magnetic field through its convective movements. 15. Which type of crust is denser? The options are A continental, B oceanic, C both are equally dense, D density varies within each type. The correct option is B oceanic. The oceanic crust is denser than the continental crust. Oceanic crust is primarily composed of basalt, a dense iron and magnesium rich rock with an average density of about 3 grams per cubic centimeter. In contrast, continental crust is mainly composed of less dense granitic rocks with an average density of about 2.7 grams per cubic centimeter. This difference in density is why oceanic crust typically lies below sea level, forming the ocean basins, while the less dense continental crusts forms the land masses. 16. The transition zone between the upper and the lower mantle is known as what? The options are A asthenosphere, B Mohorovičić discontinuity, C mantle transition zone, D mesosphere. The correct option is C mantle transition zone. The transition zone between the upper and the lower mantle is known as the mantle transition zone. It extends from approximately 410 to 660 kilometers beneath the Earth's surface. This zone is characterized by significant changes in mineral composition and density, primarily due to the increasing pressure and temperature with depth. The transition zone plays a crucial role in mantle convection and the movement of tectonic plates, as it affects the flow of materials and the behavior of seismic waves. 17. What is the term for the process by which the Earth's mantle loses heat through the lithosphere? The options are A conduction, B radiation, C convection, D sublimation. The correct option is C convection. The process by which the Earth's mantle loses heat through the lithosphere is known as mantle convection. This process involves the transfer of heat from the deep mantle to the Earth's surface, where it is eventually radiated into space. Mantle convection drives the movement of tectonic plates and is a key mechanism in plate tectonics. Heat is transferred through conduction and convection currents, causing the hot, less dense material to rise and the cooler, denser material to sink, facilitating the loss of heat through the lithosphere. 18. Which mineral is the most abundant in the Earth's crust? A feldspar, B quartz, C mica, D olivine. The correct option is A feldspar. The most abundant mineral in the Earth's crust is feldspar. Feldspar are a group of silicate minerals that make up to about 60% of the Earth's crust. Feldspars are essential components of igneous, metamorphic and sedimentary rocks, and they play a crucial role in the rock forming processes of the Earth's crust. 19. Which layer of the Earth is solid despite having extremely high temperatures? A crust, B. Mantle, C. Outer core, D. Inner core. The correct option is D. Inner core. The inner core of the Earth is solid despite having extremely high temperatures estimated to be around 5400 degrees Celsius. It is composed primarily of iron and nickel. The immense pressure at the Earth's center, which exceeds 3.5 million atmospheres, prevents the inner core from melting, keeping it in a solid state. The solid inner core is surrounded by the liquid outer core, whose convective movements generates Earth's magnetic field. 20. Which layer of the Earth contains the highest percentage of the planet's mass? The options are A. Crust, B. Mantle, C. Outer core, D. Inner core. The correct option is B. Mantle. The mantle contains the highest percentage of Earth's mass, making up to 84% of the planet's total volume and roughly 67% of its mass. Extending from the base of the crust to the outer core, the mantle is composed primarily of silicate minerals rich in iron and magnesium. It is divided into upper mantle, including the semi-fluid asthenosphere, and the lower mantle. The mantle's significant mass and volume play a crucial role in the Earth's geodynamic process, such as mantle convection and plate tectonics. 21. The process by which heavier elements sank to the center of the Earth during its formation is known as what? A. Sedimentation, B. Differentiation, C. Sublimation, D. Fractionation. The correct option is B. Differentiation. The process by which heavier elements sank to the center of the Earth during its formation is known as planetary differentiation. This occurred early in the Earth's history when the planet was still molten. During this process, denser elements like iron and nickel moved towards the center, forming the core, while lighter elements such as silicon, oxygen, and aluminium remained in the outer layers, forming the mantle and crust. Planetary differentiation resulted in the layered structure of the Earth we observe today. 22. The boundary that separates the Earth's core from the mantle is known as what? The options are A. Gutenberg discontinuity, B. Mohorovičić discontinuity, C. Lehman discontinuity, D. Konrad discontinuity. The correct option is A. Gutenberg discontinuity. The boundary that separates the Earth's core from the mantle is known as the core-mantle boundary or the Gutenberg discontinuity. Located at a depth of approximately 2900 kilometers beneath the Earth's surface, this boundary marks a significant change in the material composition and seismic wave velocities. The mantle, composed of silicate rocks, lies above this boundary, while the outer core, composed mainly of liquid iron and nickel, lies below it. This discontinuity is crucial in understanding the Earth's internal structure and dynamics. 23. What is the main method scientists use to study the interior of the Earth? The options are A. Magnetic field measurements, B. Direct drilling, C. Satellite imagery, D. Seismic wave analysis. The correct option is D. Seismic wave analysis. Scientists primarily study the Earth's interior through seismic waves generated by earthquakes or controlled explosions. These waves travel through different layers of the Earth at varying speeds and trajectories, providing data on the composition, density, and structure of the planet's interior. By analyzing how seismic waves refract, reflect, and diffract at different boundaries within the Earth, scientists can infer details about its core, mantle, and crust, forming a comprehensive understanding of the Earth's internal dynamics and composition. 24. Which layer of the Earth is most involved in the process of isostasy? The options are A. Mantle, B. Core, C. Crust and upper mantle, D. None of the above. The correct option is C. Crust and upper mantle. Isostasy primarily affects the Earth's lithosphere, specifically the crust and uppermost mantle. Isostasy refers to the equilibrium that exists when the buoyancy force of the lithosphere floating on the denser asthenosphere below balances the gravitational force. Changes in the crustal thickness of density, such as due to erosion, deposition, or tectonic processes, can cause adjustments in isostatic equilibrium, leading to uplift of subsidence of the Earth's surface over geological timescales. Thus, the lithosphere plays a crucial role in isostatic processes shaping the Earth's topography. 25. Which of the following best describes density stratification in the Earth's interior? The options are A. Layering of materials based on their density, B. Uniform distribution of materials based on their chemical composition, C. Formation of sedimentary layers due to weathering of and erosion, D. Variations in temperature across the different geological zones. The correct option is A. Layering of materials based on their density. Density stratification in Earth's interior refers to the layering of materials based on their density. This stratification occurs because denser materials tend to sink towards the Earth's center due to gravity, while less dense materials rise towards the surface. The Earth's interior is structured into layers such as the crust, mantle, outer core, and inner core, each characterized by different densities and compositions. This stratification influences geological processes like convection currents in the mantle and the behavior of seismic waves, providing insights into Earth's composition